Solving quadratic equations using the square root property. You're watching this video with Ms.Y Cavazos. So, this is the second method that can be used to solve quadratic equations, and it involves the square root. That should ring a bell. You should be thinking square root. Okay, I remember seeing that symbol. It's the radical of 2, so we call it the square root. Now, let's talk about quadratic equations just for a little bit. Quadratic equations are in the form of ax squared, where the highest degree is a 2, plus bx plus c. There are several components, several elements that make up, your typical quadratic equation. So this involves the first term is called the squared term. The middle term is called the x term. There's two x terms, except one is being squared and the other isn't. So they're two different terms. And lastly, we have our constant term, which is the number at the end, is our constant term. So it is important to understand there is a x squared term, x term, and constant term. Because for the square root, in order for us to solve with the square root, this can only work if we have the x squared term and the constant term, which means there's no x term involved. There's no middle, if you want to remember it that way. There's no middle term. X squared and constant. So with that being said, let's suppose you were given an equation like this. So you check, okay, are they giving us the x squared term and are they giving us the constant term? So what you would do next is you would try to isolate the x squared, which means try to get it by itself. So in this case, we would need to move the c over by doing the inverse operation. So this would give us x squared is equal to c once we move it over. Once you have that x squared term completely isolated, you got to think, okay, how do I get rid of that 2? You might think, oh, divide. Well, no, because if this was the case, then yeah, in this here, you would divide by 2. But this is not what we have here. So you cannot divide. This is a power of 2. The inverse of a power of 2 is if you take the square root. What you do to one side, you got to do it to the other. Just like here, we added c on one side of the equation, so you got to do it to the other side. So then we get the square root of something. Now when you square root a value, there is a positive or a negative version of it. Now this might seem a little confusing, but this is what it means. Let's say you had the square root of 4. Well, the square root of 4 could be a positive 2 and it could be a negative 2. You're probably thinking, how? Well, positive 2 times positive 2 is 4. Negative 2 times negative 2 is also 4. So that's why we take the positive and the negative version, because we don't know which one it is for sure. So let's try to apply that here for graphene. I'm sorry, for solving. We're going to find the solutions to the quadratic equations. In this case, we have a binomial. How do I know it's a binomial? Well, because there's a term here and there's another term here. They're just on opposite sides of the equation. We have the x squared term and we have the constant term. Okay, we can still continue. We're trying to isolate the x squared. Here it is. We got to get rid of that 8. 8 is multiplying the x squared, so to get rid of it, we do the inverse of multiplying, which is dividing. So we get x squared is 9. 72 divided by 8 is 9. We take the square root to get rid of the power of 2. Those are inverses, opposites of each other. So we get that x is the square root of 9, if you type it into your calculator, is 3. But we don't know if it's a positive or a negative 3. So we have that x is 3, x is negative 3. So our solutions will be 3 and negative 3. Next problem here. Again, ask yourself, is it a binomial? There's two terms, yes. Do you have the x squared term and the constant term? Yes, we do. So we solve. We isolate the x squared term. So the first thing we got to move is the 50. So we do the inverse. We subtract 50. And we get 2x squared is a negative 50. Next, well, we got to get rid of the coefficient of 2, because 2 is multiplying. To get rid of the multiplying of 2, we divide 2. And so we get that x squared is a negative 25. Again, to get rid of that power of 2, take the square root. That cancels. So we get that x is, careful, when you type this into the calculator, it's going to give you some kind of error. It's going to tell you no solution. Well, that's because we cannot have a negative radical. So when that happens, our answer is there's no real solution. And we leave it at that. Nothing we can do about it. No real solution. Next example. Okay, we can tell it's two terms, x squared term, constant term. So we solve. Move the 16 over first. So we get that 49 x squared is positive 16. Next we divide by 49. And we get that x squared is, unfortunately, 16 over 49 cannot be reduced. So we leave it like that. We still take the square root to get rid of that power of 2. We take the square root. Now what's happening here is we are taking the square root of the numerator, the square root of the denominator, and we get that square root of 16, that's just 4. The square root of 49 is just 7. Now we don't know if that's a positive or a negative 4 over 7. So we have that our zeros, our solutions, are the negative 4 over 7 or the positive 4 over 7. And this is how we would write our answer. Next example. We're trying to solve for x. There is only one x. It happens to be squared, but that's fine. We can isolate it. So we begin by subtracting the 6. And we get negative 5x squared is equal to 180. Next we divide by a negative 5. And we get that x squared is a negative 36. So when we take the square root, we're taking the square root of a negative value. That is going to result in, and once again you can type it into a calculator and it's going to tell you that this is no real solution. Nothing we can do about it. So this is how we keep our simplified answer, or our solution. Now this example is different than the rest. As you can see, the power of 2 seems to be outside of parentheses. And inside of the parentheses we have x plus 3. So we can't just subtract the 3, because 3 is trapped inside the parentheses. So that means we have to get rid of the power of 2 first. How do you get rid of the power of 2? The inverse is to take the square root. So I'm going to take the square root of one side and the square root of the other. Power of 2 cancels. So we get that x plus 3 is no longer trapped, so we don't need parentheses around it. The square root of 4 is a 2, but it could be a positive or it could be a negative 2. Now, this means that we have two cases, x plus 3 with a positive 2 and x plus 3 with a negative 2. Well, when we solve for x in each one, we're going to get that x is a negative 1 here, and we solve for x, and we get that x is a negative 5 in this one. So our zeros are negative 5, comma, negative 1. And remember, zeros is solutions. Let's try one more. Again, parentheses, different than the rest. So here is x. We're trying to get to x. X is with 8, and they're both trapped inside parentheses, where there's a power of 2, but at the same time there's a 2 at the very front. That 2, that coefficient of 2, is multiplying the parentheses. So let's begin by doing the inverse of multiplication, which is division. So we would divide by 2 on both sides. We get rid of that 2, but we still have the power of 2. 512 divided by 2 is 256. Next, now we get rid of this power of 2 by taking the square root, taking the square root. Finally, x minus 8 is free, no more parentheses. And we get that the square root of 256 is 16, but we don't know if it's positive or negative. So, we're going to have to break this into two options. X minus 8, positive 16, or x minus 8, negative 16. And so we solve for x. We add 8 on both sides. So here we get that x is 24. And on this other linear equation, we add 8. And we get that x is a negative 8. So our zeros, and I'll write the answer over here, are negative 8, comma, positive 24. Now there's an alternative way of breaking this up, and I'm going to show you, in case you get confused. We're trying to solve for 8. So we're trying to solve for x. So I'm going to move x, and now we're going to have to add it over here. So we get that x is plus or minus 16 plus 8. So that means x is either 16 plus 8, or x is either negative 16 plus 8. Either way will result that x is 24 and x is negative 8, which are still the same solutions that we obtained the other way. Okay, I hope this helps. Thank you for watching.